G'day team, welcome back to another video. So we are actually continuing on today with our vectors work. So we're going to start looking at vectors in the plane. Now, it's very bad, but I threw up a meme, alright? We've got our guy, Vector, lots of vectors, and he's in the plane, alright? I know, terrible joke, but get that over and done with, and we get into the maths. So, when we plot points on a Cartesian plane, we move in the x direction and then the y direction. That's actually how we read our coordinates. So for our point T, 5, 3, we actually move across 5 and we move up 3. We look at the x and then the y movement, okay? So we can write translated points in relation to the origin as vectors, all right? And we write this as A, B, okay? So it's a 2 by 1 vector, okay? So we've got the x on top and the y on the bottom. So A is the horizontal change and B is the vertical change, all right? So for my vector here, O to T, O being the origin, T being the point, my horizontal change is 5, so we put 5, and then our vertical change is 3, positive 3, because we've gone up 3, okay? If I was going to the left on my x, it would be negative. If I was going down on my y, it would be negative, okay? We'll see that in a second. So suppose we have these vectors I and j, where I is equal to 1, 0, and is a 1 unit horizontal translation. J is the opposite. It is 0, 1, and is a 1 unit vertical translation, okay? So both are what we call base unit vectors, and these are super useful, and we're actually going to use I and j quite a bit in the next coming chapters, all right? So then we actually have our vector OT is equal to 5 times by this vector I plus 3 times this vector j, because we're moving 5 lots of 1 units horizontally and 3 lots of 1 units vertically, okay? Or we could write this as 5 over 5, 3, vector 5, 3, is equal to 5 times I, which is 1, 0, plus 3 times j, which is 0, 1. So, for any point P that has the coordinates x, y, P has the position vector, either OP, you can write it in vector form, equals x, y, we call this component form, and then we've got x times by vector I plus y times vector j, and this is what we call unit vector form, okay? So we do have a couple new terms thrown into the mix here, component form and unit vector form. So the easiest way is probably just to look at an example, right? Okay, so write the following vector in component form and vector form. So I've gone ahead and actually written in here my horizontal translation across, so we've gone across 6 units, then we've gone down 2 units, so that's my vertical translation. Now, hopefully you're already thinking to yourself, so in component form we need our x change and our y change. So we've actually got 6 and negative 2, so remember, moving to the right is positive in the x, but because we're moving down, we've actually got a negative vertical translation. That's why we get negative 2 here. And then in unit vector form, this is 6 times vector I, take away 2 times vector j, okay? It's as easy as that. So hopefully you guys are able to now attack the questions 1 through 5 of chapter 3C in the Hazy 11 Spec textbook, all right? Have a crack at those questions and join us again next time for some more vector work.